Okay, so that's been a lot of new stuff here. But then, okay, so the chapter has got a lot of stuff because it's assuming you don't know anything about matrix multiplication. It's introducing to you matrix multiplication as if you've never heard of it before. So you don't need, like, it's good, showing you matrix multiplication is not commutative. So it seems long, but the new stuff for you is relatively small. It's just the stuff with the connection between maps and matrices. So there's a lot of extra stuff here, and it points out that all the rules, the matrix rules, correspond to matrices and matrix products, and there's sort of one image in maps, one image in matrices. Okay, and you have inverses. You have map inverses. If I have composition. If I have a composition here, let's go to my. Okay, I'm recording. Okay, so inverses. If I have a map F from V to W, and it is a correspondence, it's 1-to-1 and onto, and it's not from V to W, it's from V to V. Let's say the map F is from V to V and it's 1-to-1 and onto and linear. So it's a linear, it's an isomorphism. Okay, in this case, it turns out that there is a map F inverse from V to W, from V to V, such that V circle V inverse equals the identity map. That's the sense in which it is an inverse. How does that work? Well, let's do this simple example where so we can see it with like numbers 1, 2, and 3. Let's say we have A. Well, we actually don't need, they don't have to be exactly the same. 1, 2, 3, 4, 5, 6. So let's say 1 to 6, 2 to 5, 3 to 4, right? So that F of A equals sum B. If A is 1, then B is 6, like that. Well, we can then, if this is F, we could define a map here back to A, where we reverse the arrows. Like if 3 went to 4, then 4 is going to go to 3. And if 2 goes to 5, then 5 is going to go to 2. And if 1 to 6, then 6 is going to go to 1. So I just reverse the arrows, right? So that's what we're going to, because you notice what's happened is here we have F inverse of B equals sum A. Well, let's see what the composition is of F circle F inverse, right? Well, F inverse, well, let's do it the other way around. Let's do it with F first, then F inverse. So if this is going to be defined as F inverse of F of A for some A in here. Well, let's see what this does. If I take A as 1, right? If this A is 1 here, this would be F of 1. That's 5, and F of 5. No, F of 1 is 6, and then let me do it one by one. F inverse of F of 1 equals F inverse of 6. F inverse of 6 equals 1. So that means 1 goes to 1. And you can see it's going to continue along this line. F of 2 equals F inverse. Well, 2 goes to 5. F inverse of 5 gives back 2. So F inverse is the map that undoes F by reversing the arrows, the arrow diagram, okay? So that's just what you mean by so the inverse in maps is the composition inverse, right? Okay, so let's say that we have then a map F now from V to W, right? So let's then there it turns out that for sometimes, see, if this map is 1-to-1 and onto, then it's going to turn out there's a map F inverse from W to V such that F circle V will equal the identity map on W, and F inverse circle F will equal the identity map on V, right? Because this one starts with V, goes to W, comes back to V. Well, so if I just choose a random map here that's 1-to-1, it might be hard to find F inverse, right? Because let's do an example for this, maybe. Let's say that I went X and Y. Well, where am I going to have maps that are 1-to-1 onto? It's only when they're the same dimension, right? So this can't be like a 2-dimensional, 3-dimensional, or 3-dimensional, 2-dimensional. They have to be 2-to-2 or 3-to-3. So if I want to have an isomorphism here from, say, F, this is going to have to be F to, say, X plus Y, X minus Y. There's a linear map, right? So now we could check that it's 1-to-1 and onto, right? Let's say that it is. Then there's going to be some map F inverse that will undo this. But I'm not exactly, I mean, maybe it's obvious or something, but it's not so clear if I start from, say, R and S, how do I undo this, right? So what I can do is say, well, F has some representation as a matrix F, and it's going to turn out that the representation of F inverse will be the matrix inverse of this matrix here. So I can then go and find this map through the matrices. So let's find, for this map, let's find what F is. Well, we have to find what the basis action is. What's 1, 0? 1, 0 is 1, 1. And what is 0, 1? Well, that is 1 minus 1, right? So F, this is actually F here. So the matrix F equals 1, 1, 1, minus 1, right? So let's see what the inverse is. What's the inverse of this map? Well, to do that, you remember the giant augmented matrix there, and then we can do minus row 1 plus row 2 to get 1, 1, 1, 0, the first row, and then minus 1 plus 1 is 0. Minus 1 plus minus 1 is minus 2. Minus 1 plus 0 is minus 1. And minus 0 plus 1 is 1. Okay. And then we have to get this to reduced row echelon form, so it's the identity matrix. And so what I'll first do is 1/2 row 2 plus row 1. That'll get rid of this 1 here. It's not going to change the second row. But so it's a 1/2 of 0 plus 1 is 1. 1/2 of minus 2 is minus 1, which will get rid of that one. And then 1/2 of minus 1. 1/2 of minus 1 is minus 1/2 plus 1 is 1/2. And 1/2 of 1 plus 0 is 1/2. Let's see. I think that's right. Okay. And then the final thing is we can do minus 1/2 row 2 to get 1, 0, 1/2, 1/2, 0, 1, 1/2 minus 1/2. Okay, and so we think that the inverse of 1, 1, 1 minus 1 might be 1/2, 1/2, 1/2 minus 1/2. And the only one we can check for sure, apart from hoping that arithmetic was right, was to do so do the matrix, but we can see if we get the identity matrix. So 1/2 plus 1/2 is 1. 1/2 plus minus 1/2 is 0. And then 1/2 plus minus 1/2 is 0. And then 1/2 minus 1 times minus 1/2 is 1. So it checks out. So here's the inverse. So here's the inverse map, the inverse matrix. But let's say let's use the matrix to find what the map action is. We can multiply this F inverse times a vector and get 1/2 x plus 1/2 y and 1/2 x minus 1/2 y. Okay. So let's see. So the first action was, so fx from xy to x plus y, x minus y, and apparently F inverse x, x, y to, and I'm going to see this, if this is correct, I can pull out the 1/2 and be 1/2 x plus y, x minus y, right? Well, that certainly seems reasonable, right? But the question is, does it really work? I mean, if I do these two maps, I get the identity matrix. So if I act with one of these on a vector, I should get the same vector back. But what about how does that work out here? Well, let's choose let's choose F inverse circle F of, say, 1, 2. Okay, well, that's going to be F inverse of F of 1, 2, which equal F inverse. So what's F of 1, 2? Well, that should be x plus y is 3 and x minus y is -1, right? And then if I act with F inverse, well, x is now 3 and -1. So that should be x plus y is 2 divided by 2 is 1 on the top. And then on the bottom, it should be x minus y, which should be 3 minus a -1, which is 4. 4 divided by 2 is 2. So somehow it did work. You get out the same vector. Although, looking at this, it's not obvious that this is somehow the inverse of this, right? I mean, maybe you'll see, maybe there's some logic to it, but it seems like that if I send xy to x plus y and x minus y, then the inverse is sent to this, is sort of doing this, looks the same except with the 1/2. And there is something there. I mean, maybe you can understand. It's like when you look at but the point is, we got this inverse from finding the matrix inverse using Gauss's method, and then going back to finding the map action. Okay, so these are some of just the some of the stuff you can play with inverses here, and they're introducing the idea of inverses in the first place, as if you didn't know what an inverse was, and they actually then are going through and introducing this this whole method of the giant augmented matrix method. Okay. And at the end of this chapter, there's some special matrices, a zero matrix, a unit matrix that I wanted to sort of not dwell upon. We can come the identity matrix, things like that, the diagonal matrices. So these are just definitions of some special. And then we introduce the elementary matrices, which you already know about. So most of the stuff you've already seen before. Okay, so I think of this chapter, we've hit most of the stuff that's going on, right? However, one of the things that so that sort of sums up what you want to do. You've got this with representing maps with matrices.